we are looking at transforming graphs from a given graph, not an equation. Without having the equation, you can't just type into the calculator. You're going to have to know what and how differing things affect the equation. If I have the equation f of x and I take minus 2, that is a downward movement 2. All of the points in the original function f of x are moved down 2. The x value stayed the same, so we say that this minus 2 affects the y value. If we have the x minus 2 inside the function, it is a right movement of 2. All of those points then move right, which tells you that we have it affecting the x value, not the y value. All of these points would move over 2, over 2, over 2. And it makes it look more like a mountain, but we would trace over those two. And we say then that this is affecting the x values when it's happening inside the function. If you have a value in front of that you're multiplying, think of this as your f of x being the y value. So you're finding your y value, your output, and multiplying all of those y's by 3. So it's affecting the y value. All of these points then, we have a negative 2, 2. Well, this negative 2, 2 point is going to go negative 2 to 6 because we're multiplying the output y that was at 2 by 3, and 2 times 3 is 6. 0 times any number is still 0. My intersection points then would be the same. All right, let's draw another graph. That's getting kind of busy. And let's look at more than one movement. Say we have 1/2 f of x minus 1 plus 3. This 1/2 is multiplied by the output y. So the 1/2 is a shrinking vertical by a half and then a plus 3. And the plus 3 is also affecting the y value. The x minus 1 is affecting the x value. Let's say I have a point, the absolute value of the point. Okay. And I've moved it, so this is going to be my original V shape, okay? And I know I have some nice little points in here. I'm going to take my left point, negative 4, 1, and the negative 4 is the x value, and I'm going to add 1, which puts me at a negative 3. I'm going to take half of 1, which is a half, plus 3, which puts me at 3 and a half. So my new translated point is negative 3 and up 3 and a half. The point negative 3, 0, I take the x value, negative 3, and I add 1. It puts that new point, negative 2. Half of 0 is still 0, plus 3. Negative 2, 3. My point, negative 2, 1. I will add 1. Half of 1 is a half, plus 3 is 3 and a half. As you can see, this graph has been vertically moved up, but it also has been widened. If I have a function and I am multiplying times 2 inside the function, this value affects your x values, and it's the opposite operation. You take all of your x values and you take half of it. The point that was negative 4, 1 becomes negative 2, 1. Negative 3, 0 becomes a negative 3 halves, 0. And the negative 2, 1 becomes a negative 1, 1. Negative 2, 1, negative 1.5 and 0, and negative 1, 1. The last one I want to look at is the absolute value. When you have the absolute value, absolute value is how far a number is from 0 on the number line. So we'd say that those absolute values are positive. Where are the outputs on a graph positive? Well, it's above where the y values are positive. The outputs are the y values. All of these values that are below are negative values. So if I want the absolute value of f of x, I go to my intersection with the x-axis, and all of these points are going to move up. Now, all of the ones that were already there are going to stay in the same direction. So I just trace over the other ones.